me. Oh, okay, I gotta put my name in here. All right, so I do not believe I am female, so I'm not gonna write my name in any of these 4 spots. I think I'm wearing blue today. Yeah. And I believe I'm wearing glasses. So I think I belong in this area. I don't think y'all can see that, can you? Just the people in the front row can really see it.
Yeah.
So what I've got here is I've got 3 groups, 3 classifications. Everyone who's in the is female circle, would y'all please stand up? If you're female, please stand up. Because you wrote your name in the is female circle, right? Okay. Notice that some of y'all are wearing blue. Some of y'all are not. Some of y'all are wearing glasses. Some are not. But you're all in this female circle, right? Okay? All right, go ahead and have a seat, please. Everyone who's wearing glasses, stand up. Notice that in this particular example, everyone who's wearing glasses also happens to be wearing blue. If you're wearing glasses and not wearing blue, you would be down here, depending if you're male or female. Okay, go ahead and have a seat, please. These are predicates, aren't they? Who wears glasses? Well, Mr. Potter wears glasses. Lorenzo wears glasses. Raven wears glasses. And Alyssa wears glasses. Lots of people wear glasses in here. So I could use the capital letter G to represent wears glasses. And for the people who aren't wearing glasses, I could use negation G. And in that same idea, I could use F for is female. Or I could use B for wears blue. And there are 8 regions in this diagram up here. And there are 8 rows on a truth table if I have 3 statements. Because for every person in here, I can ask the statement, is blank female? And the answer is either true or false. I could ask, are you wearing glasses? And the answer would be true or false. So when I look at this, true, 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 false, 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 false. So I've got this part of my truth table, and of course the second column is going to be
True, true, false.
True, false, false. True, true, false, false. And the third column?
True, false, true, false, true, false.
So tell me about this first row. Is female. Is wears glasses. Wears blue. Where are they on this diagram?
On the
Those people are female, wearing glasses, and wearing blue. Right? How about these people? I've got false, true, false, which means what? Not wearing blue.
Is wearing glasses.
Is wearing glasses.
Is not wearing blue.
Not female, right? So that describes a person that's female, wearing glasses, not wearing blue. So not female, so they can't be inside this circle, so they have to be in this outside part. They have to be wearing glasses and not wearing blue. Now, no one in the class fell into that category. But if they did, that's where they would have written their name. And then I've got one more. Tell me about this last row.
No one's wearing
Not female, not wearing glasses,
and not wearing blue.
not wearing blue. So you can picture a person like that, right?
No.
A guy who's not wearing glasses and is not wearing blue? Probably wearing like a lot of black or a lot of red or maybe green or something like that. Okay? Where would they write their name?
On the outside.
Yeah, they would have to be outside of the female circle and outside of the blue circle and outside of the green circle. So they'd have to be outside completely. Does that make sense? Now, what we're talking about is we're talking about something called Venn diagrams. This is a way to illustrate these predicates that we've been talking about. So what I want to do is I want to jump to the worksheet that I passed out to you. So I want to take a look at this first diagram. This is another diagram with 3 circles on here. I've got one circle that says English, one circle that says history, and one circle that says math. I want to bring to your attention 2 parts to this that seem like they're asking similar stuff, but they're actually asking very different stuff. Part A says, how many students are taking history? Part D says, how many students are taking only math? Now, where can I find people that are taking history? Which group? The history group. So tell me a number you see.
14.
14. These people are definitely taking history, right? Oh, these 17 people are also taking history. They just happen to be taking English as well. Anyone else taking history?
6.
These 6 people are also taking history. They just happen to be taking English and math.
And 10.
And these 10, they're also taking math as well. So if I want to know how many people are taking history, what do I need to do with these numbers that I've underlined in blue? I need to add them up. So what is 17 plus 6? 23. 23 and 10?
33.
33. And 33 plus 14 is 47. So 47 people are taking history. I want to compare that question to question D, which says how many students are taking only math?
34.
Now I know these 34 are taking math. Is anyone else doing only math?
No.
These 3 people are doing math with English. These 10 people are doing math with history. These 6 people are doing math with everything. So my answer to that question is going to be 34. What's the difference between the questions? Yes? The word only, that's the big difference there. That word only is a distinction I'm going to have to watch out for. If I don't see the word only, then that means I'm going to be inclusive in many different groups. So if I ask the question, how many people in here are not female? Would you all stand up, please, if you're not female? Okay. Notice that I'm including people who are wearing glasses. Notice that I'm including people who aren't wearing glasses. Okay, so have a seat. It's important to denote who's in which group and if I'm counting people from more than one group. So let's take a look at Part B. Part B wants to know how many people were surveyed. So if I want to know how many people were surveyed, what would I do? Add all of them up, including these people that would be out here. How many are in that category? 0, because none of them are listed, right? So let's see, we just added up this circle. We said this circle added up to 47. What's 47 plus 20? 67, and 3 more make? 70, and 70 plus 34. 70 plus 34 is 104, right? 70 and 34 is 104. Hard math, I know. How about choice C? What is choice C asking for?
For taking English but not history, so English and math.
So math and English, but not history. So where would I find those people? They're not going to be in the middle, because the middle is 6. That's taking everything.
The side.
Math and English, and not history. It's the 3, isn't it? These people here. So notice that when I give you specific values, are they taking math? Yes. Are they taking English? Yes. Are they taking history? No. I'm telling you specifically which groups they're in. And when I tell you specifically which groups they're in, well, that makes it very easy to say, oh, it's in this circle, it's in this circle, it's not in this circle. And so it's got to be the 3. So how about choice C? How many are taking only 2 subjects?
3 and 10.
30.
3 and 10 and 17, right?
Yes.
So that adds up to 30. How many are taking only 1 subject?
34.
These 34
40,
and these 14, that makes 48,
and 20.
and 20 makes 68. So notice that I've got these 68 which are taking only 1 subject. I've got these 30 that are taking 2 subjects. And then I've got these 6 people that are taking all 3. And altogether, if I were to take 68 plus 30 plus 6, that adds up to the 104 that are taking all of my things. How many people were surveyed? 104. Okay. All right, so let's take a look at number 2 then. Notice on number 2, I've got some information about the whole circle, but I'm missing information from the regions inside. I know that this blue circle adds up to 200. Everything inside this circle adds up to 200, but I've got a missing value inside. How much do the known values add up to? I've got 20 and 10 and 50, that's 80. And how many are left over from that 200?
20.
120. I'm just going to subtract them. So choice A has 120 people in it. In this red circle, the red circle adds up to how much?
100.
100. But how many have I already accounted for? These 10 and these 30 and these 50. So there are 10 left over. So choice B is 10. And then I've got choice C. Choice C wants to know how many are in the orange circle. So how many are in this orange circle down here? I have to add them all up. I have to add the 110 and the 120. That adds up to how much?
230.
That would be 230, and 10 more make 240, and 50 more make 290. So this orange circle adds up to 290. So keep in mind that on some of these problems, I'm going to have to subtract from a total to figure out how much are in one of those regions. So any questions on 1 or 2? Let's jump down to 3. 3 says, students were asked to name their favorite action-packed movie. 22 named Godzilla. 15 named Armageddon. 10 named both Godzilla and Armageddon. Now, I'm looking at this diagram for number 3. Why are there 2 circles here?
Because they're only asking about 2 subjects.
There's 2 options. What are the movies that we can choose from?
Godzilla or Armageddon.
What would be a good letter for Godzilla?
G.
G. What would be a good letter for Armageddon?
A.
A. So I'm looking at this. I've got 22 named Godzilla, 15 named Armageddon, 10 named both Godzilla and Armageddon. Which number should I start with?
22. The outside.
22? 22 liked Godzilla, so that's these people here. These people like Godzilla, right?
Yes.
Don't these people like Godzilla as well? They do. They both like Godzilla. That means those 2 spots together have to add up to 22. Am I going to split them evenly?
Yes.
No.
Why not?
One had 10 and one has a...
Yeah, one of them had 10. 10 named both Godzilla and Armageddon. Which group liked both movies? But where is it in the diagram, though?
It's in the middle.
The middle. These people liked both movies. So if 10 people liked both movies, how many liked only Godzilla?
12.
Well, 22 people liked Godzilla, but how many only liked Godzilla?
12.
12 did. Where did that 12 come from?
So subtracting 10.
I had to do
from
22 minus 10. The whole circle has to add up to 22, just like this whole circle had to add up to 100. But I've already accounted for 10 of these people because 10 of these people liked both movies. 10 of these people are in the overlap region. Now, how much are going to be in this spot here that only liked Armageddon?
5.
5. How did you figure that out?
Because 15 minus 10.
Okay. I know that 15 named Armageddon, but 10 liked both. So let's take a look at problem 4. It says students were named to ask their favorite sport. 37 named soccer, 16 named basketball, 12 named football, 3 named soccer and basketball, 2 named basketball and football, 1 named soccer and football, and 1 named all 3. Why do I have 3 circles here?
Because we're talking about 3 predicates.
Okay. I've got 3 different predicates. I've got soccer, I've got basketball, and I've got football. Now, what did we learn from the previous example? Okay, where should we start? Where should we start?
Middle number.
The middle. What is this middle region, this triangular region that we've got here? What does it mean?
It means all of them.
All of them. How many people liked all 3 sports?
1.
1. How do you know that?
Because
And 1 named all 3. That's how we know that, right? So let's start working our way back. Tell me about this football-shaped region here.
how do you say like soccer and football?
They like soccer and football. Now, some of them like basketball, and some of them don't. How many people like soccer and football? 1. That means this football-shaped region has to add up to 1. And that one person, does it like basketball or doesn't like basketball?
He likes them all.
He likes them all, doesn't he? So how many people like soccer and football but not basketball? 0. Because it has to add up to 1. So describe this region for me here.
People that like soccer and basketball.
Soccer and basketball. Now, some of them like football, some don't. How would I figure out how many don't like football?
We would have to go from
Which value in the word problem is going to help me with
3.
that? The 3. They told us that 3 named soccer and basketball. One of them also likes football. So how many don't like football?
2.
2. Because together this has to add up to how much?
3.
3.
Oh, I understand.
So how would I figure out how much goes in this blank?
You would have to get the value of 2.
Okay. Basketball and football.
1.
And then how many don't like soccer? Just 1. Because together they have to add up to 2. All right, so how about this circle? Describe this bottom circle for me.
People like football.
They like football. How many people like football?
12.
12 people liked football. But we've already included how many people?
2.
That leaves 10 people that like only football. These 10 people, these are my only football, right? But altogether, 12 like football. The difference is some like it only. Some that's their only favorite sport. So how would I figure out this value here?
Only basketball.
Only basketball. How would I figure that out? Well, 16 like basketball overall.
Subtract 3 more. 4.
Subtract 3 or subtract 4?
4.
Yeah, I've got to include all of these regions, don't I? Because all of these people like basketball.
So 12.
So 16 minus 4 is 12. How about this region?
37.
37 minus
3.
3, which is
34.
34. Okay. So any questions on the front?
No.
All right, so let's take a look at the back. We're only going to work through a few problems on the back. This is only notes. This is not your homework. Remember, your homework is the problem 1 and 14 through 18. So on problem 5, it says, in a class of 50 students, 18 take chorus, 26 take band, and 2 take both. How many students in the class are not enrolled in either chorus or band? So I need to come up with a diagram. Tell me what this diagram should look like.
It should have 3.
3 circles? Tell me what are in the 3 circles.
Chorus,
Chorus,
band,
band.
and
It's 2 circles.
I think 2 circles might be good. I think chorus and band is really all we need. I know I need a circle for chorus. I know I need a circle for band. And the spot here is the people that are in both, right? And if they're not in chorus and they're not in the band, that's kind of like this region that I have completely outside all three circles. It's kind of like the guy who's false, false, false. He's not female, not wearing glasses, not wearing blue. What we've learned is that in a Venn diagram, where do we start?
The middle.
We start in the middle. What does the middle represent?
2.
2. What does that 2 represent, though? Those two people like what?
Both.
They like both chorus and band. So now what do we do?
Now we have to do
Okay. So tell me about the chorus.
18 minus 2.
18 people take chorus. We've already counted 2 of them. So there are 16 left over. Then what?
You take your band. 26 minus
26 minus the 2 that like both. That's 24.
4.
Now how many people have we counted up so far? 16 and 24 make
40.
40, and 40 plus 2 is
42.
42. So
42.
I need to subtract 50. They told us 50 students, and we've already accounted for 42 of them. That's going to leave how many?
8.
8. So in answer to our question, how many students are not enrolled in either band or chorus? 8 students are not in both. Or in either, I should say. So I need to draw the picture to figure out what's going on. So let's jump down to number 7. On number 7, it says, a veterinarian surveyed 26 of his patrons. He discovered that 14 have dogs, 10 have cats, and 5 have fish. 4 have dogs and cats, 3 have dogs and fish, and 1 has a cat and fish. If no one has all 3 kinds of pets, how many patrons have none of these pets?
3.
Why 3 circles?
Because there's 3 predicates.
There's 3 options. There's 3 pets listed. What are they?
Okay.
Okay, we've got dogs, we've got cats, and we have fish. And we talked about how when we're doing a Venn diagram like this, we should start where? In the middle. So describe the middle for me. What does the middle represent?
It represents all of them.
All 3 pets. Plus 5.
16.
16 and 1. 17 and 3. 20. 20 and 1 make 21. And we had 26 patrons.
So 5 people don't have.
So that's 5 people that don't have dogs, cats, or fish. So they have ferrets, or they have iguanas, or they have turtles, or they have something exotic, right? Maybe a ferret or 2. Monkeys. Wild tigers. You know, whatever it takes. All right, so let's jump down to number 9. Number 9 says 100 people are interviewed. 75 of them drink Coke or Sprite. 35 drink Sprite. 20 drink both Coke and Sprite. And then we have questions about this. So describe to me the Venn diagram.
There's 2 circles.
2 circles. What are they?
Coke and Sprite.
Coke and Sprite. Okay? Now I've got these values that I need to fill. 75 of them drink Coke or Sprite, 35 drink Sprite, 20 drink both Coke and Sprite. So which one is this middle that we're supposed to start with? The 20. Those are the 20 that like both drinks. So I need to put 20 there. How many like Sprite?
35.
35. So do I put 35 here?
No.
Yeah, I've got to subtract it because I want to know how many only like Sprite. So what's 35 minus 20? 15. And then they told us that 75 of them drink Coke or Sprite. I already know that these people drink Coke or Sprite because they drink Sprite. So if I want to figure out how much is left over for that spot,
You have to add those 2.
add them together and
And subtract by 7.
subtract from 75. So what's 75 minus 35?
20. 45.
40.
Should be 40, right? So then the question is, how many people like Fanta or A&W or Mountain Dew or some other exotic drink?
Water.
Why is everything exotic?
Well, because it's not Coke and it's not Sprite, which we
It
know
could be
stuff
water.
about.
Does that drink soda?
Water, yeah, that's an exotic drink.
Yeah.
5 people.
They told us that 100 people were involved, right?
Yeah, it's 5 people.
5?
What?
So if you took 40 plus 20,
75?
Wait,
25 people.
yeah, that's all 75, isn't it?
25.
Yeah.
So this should be 25. That's all 4 regions, isn't it?
Yes.
So let's take a look at the questions. First question says, how many only drink Coke?
40.
40. How many only drink Sprite?
15.
15. And how many drink neither?
25.
25. To note that we usually start in the middle when we're doing these. And we work our way outwards. We're usually going to have overlap. And how do we fix overlap? We subtract, exactly. We're going to take away. All right, so there's one other worksheet that I want to talk about, so let me pass that out to you real quick. This sheet that I just passed out, I want you to keep this sheet. This is going to be our notes for tomorrow as well. We're going to work primarily on the bottom part of this. So I want to talk about these symbols that we're going to be using here. So the first part I want to talk about are 14 through 22. So I want to know if these values can be found in these groups or these sets. In other words, if I look in the set marked A, am I going to find a 3?
Yes.
Yeah. And if I do, then I'm going to use this element symbol, this E symbol.
It's like a,
But if I look at number 16, if I look in set C, do I find a 6?
no.
Is there a 6 in this set E? So that's why I'm going to use the element symbol with a slash through it. So that's what we're playing here. I want to know, is it in the set or is it not in the set? So on number 15, is 7 found in B?
Yes.
Yeah, it's right there. So that is an element. On number 17, is 9 found in D?
Yes.
Yeah, as a matter of fact, that's the only thing that it includes. Is 16 found in E?
No.
No. Is the letter B found in H?
No.
H is right here. No. Is the letter C found in G?
Yes.
Yeah, it's right there. Is the letter phi found in set I?
E.
Well, yeah, set I has these Greek letters. I've got theta, I've got omega, I've got sigma, I've got phi, I've got delta, and I've got xi. Is it found in there?
Yes.
Yeah.
I think it is. I think it's right there. How about the letter xi? Is it found in set H?
No.
What does set H contain?
Contains A and D.
A and D. No Greek letters, right? So that's the first idea. The idea is that I can use this symbol if it can be found, and I use this symbol if it's not found. So I have 2 different symbols that I'm talking about. Is an element of, or is not an element of. On 23 through 30, I want to know if everything in B is an element of A. In other words, can I find everything in B in A? Is 1 in A?
Yes.
How about 3? Is 3 in A?
Yes.
How about 5?
Yes.
How about 7?
Yes.
So if everything can be found, I'm going to use this long C to show that it is a subset. In other words, everything in the first set can be found in the second set. How about on 24? Is everything in D findable in C?
Yes.
Yes.
9's the only thing. Is it here? How about the other way around? Is C findable in D?
Yes.
No.
No.
Is 5 in D?
Oh, no.
Is 7 in D?
No.
Is 11 in D?
No.
So because everything's not findable, I have to do a slash through it.
What's that?
Okay? Is D findable in E? D is a subset of E. Is E a subset of A?
Yes. No.
Is everything in E found in A?
No.
No. What's missing?
13
The 14 and 15. Is G a subset of F?
E and F. No.
No. What's missing?
X.
X is missing. Is H a subset of F?
Yes.
Yeah, because everything here is found, right? Is J a subset of I?
Yes.
Is it? Got omega. Those match. I've got sigma. I've got phi. And I've got delta. Yeah, everything's found, so that is good. So I've got two marks here. I've got this if it's a subset, and this mark if it's not a subset. So in other words, I can tell if one particular object or element is in a set, and I can tell if multiple objects or elements are found in a set. So the last thing we're going to talk about today is how to come up with new sets. And so I've got this upside down U, which reminds me an awful lot of the upside down V. The upside down V that we talked about said that it's in one and the other. That upside down V means and. So tell me what's in both A and B. In other words, what's in both sets?
1,
1 is?
3, and 5.
2 is not in both sets. 2 is only found in one set. But 3 is?
7, 5,
5.
And 5 and 7. Any others?
Yeah, no.
Okay. So what we're doing is we're creating a new set that contains the elements that are found in both sets. In other words, where they overlap. This upside down U is called intersection, but it's really my overlap. In other words, what do they have in common? So if I look at 32, I want to know what B and C and A all have in common. What do they all have in common?
1,
They all have a 1?
7,
No, 5.
5 and 7 and
They all have a 5?
yeah.
5 and 7.
They all have a 7. Now, some people have problem drawing these braces. If you draw a bracket with a little mark on the side, that's probably the easiest way to do it, and that's perfectly fine for our purposes. If you can draw those squiggly braces, then please try. Now, just like the upside down U is like an upside down V or an and, this right side up U is just like a regular V, which means or. So I want to know what's in one set or the other set. In other words, I'm going to come up with a set that may be bigger than either of the two sets I'm dealing with. I'm taking E and D, and I'm finding out what's in one set or the other set or both sets. So tell me what's in one or the other or both. 9 is? Anything else? Well, 7's in one of the sets, isn't it? And 14 is? And 15. Remember that if I'm doing a union, if I'm doing this or,
That means all of them.
I'm essentially squishing the two sets together. And if anything's a duplicate, I only count it once. So tell me about F intersect G. What do F and G have in common?
B and C.
B and C. Remember, if I see the intersect symbol, if I see the upside down U, I'm talking about what they have in common. But if I have H union G, I want to smush them together. What happens when I smush G and H together?
A, D, B, C.
I get A and D and B and C and X. Now I want to mention order doesn't matter. It doesn't matter which one comes first. So I could say A, B, C, D, X. Because alphabet, yay.
Yay.
I could do B, C, X, A, D because I decided to do set G first and set H afterwards. The order doesn't matter, but it should have how many things in it?
At least 5 letters.
Should have 5 letters. It should have the A and the D, and it should have the B, C, and X. How about I intersect J?
I intersect.
What do they have in common?
The omega.
Omega,
Alpha.
sigma,
Phi.
phi,
And they have alpha.
and delta. It's okay. It's all Greek to me too. If I do I union J, then I'm smushing them together, and so I should end up with something that's bigger. So in other words, I'm going to have everything that we had before, but I'm also going to have theta, omega, sigma, phi, delta, and the Greek letter C. What's important to note is it doesn't matter if I'm talking about numbers or letters or Greek letters or colors or cars. These are all objects. They might as well be names on a board. These last 3 examples, tell me about D union H. What happens when I smush D and H together? What do I get? 9A, and D. Yeah, we can mix them. That's fine. I can have letters and numbers in the same set. Tell me about D union G union J. What happens when I smush all three of those sets together?
You get
D has a 9 in it. What does G have? BCX. And J has 4 Greek letters, right? We're going to have omega, sigma, phi, and delta. All right, it's time for the trick question, number 40. Tell me about A intersection J. What do A and J have in common? Nothing. So in other words, if I draw my braces, there's not going to be anything in between them. And this is something that we call an empty set. So please bring this worksheet back tomorrow. We're going to go ahead and finish the top part of it, and we're also going to finish the back of it. Your homework, remember, is on the new set of problems. It's 1 and 14 through 18 on your packet. That should finish our packet for us, by the way. And also, don't forget that your problems 46 through 52 are due to your PA before the end of the day. Does anyone have any questions? All right, then I release you to your PA. Have an awesome day.